Hi, my name is Connie Anderson. This is a short presentation I had on the HLAA board meeting in Milwaukee. I've been asked to send a copy of this presentation, and I've included some comments in order to make it a little more useful and understandable. As the chairman of the International Loop IEC standard, I will give you some short notes what you should demand of a modern loop system. I will also give you information of different wireless systems, basic functioning of loop system, and listening examples for better understanding. I'm responsible for the electronic design of Univox loop amplifiers in Sweden. They made the world's first real current constant loop amplifier. The quality has really increased in last years with new concepts of modern loop systems and a tight standard, which I hope you will find on the following slides. Just briefly, IEC is an international standard organization. United States is included for all fields of electrotechnology, including hearing aids and hearing loop systems. The IEC 6118 standard harmonizes worldwide the coil sensitivity for the hearing aid and the level of the loop for good system function. It is therefore very important that the level of the loop follows the standard so that it matches the sensitivity of the hearing aid. Let's start with some whys. Why isn't a hearing instrument enough? Why do we need a wireless system when the user already has a personal fitted hearing instrument? Well, sound in air is problematic. It adds many different disturbances to the original sound itself, reverberation and human speech noise being the most problematic disturbances. But let us listen. Here's a recording direct from a hearing aid through an artificial standardized air. The reverberation time is 2 seconds, the speaker is about 4 meters distance from the hearing instrument, and there are bubble noise from the chatting people as well. Please listen to this. The speech is cluttered with mostly reverberation and some cocktail noise from chatting people. This is the situation for many hard of hearing just using the hearing instrument. It is truly impossible to hear what's been said. It's very difficult to filter out the reverberation, and it's really impossible to filter out speech from speech. So actually there is just one solution: shorter microphone distance to enhance the signal to noise ratio. There are different wireless techniques like system based on radio, infrared and loop systems. Well, radio and infrared receivers have certainly larger current consumption compared to hearing instrument. Typical current consumption of a hearing instrument is 0.3 to 1.5 milliamps. It's not compatible with a hearing aid, and you need to have a neck loop or some other device in order to connect it to a hearing aid. You need to have a separate unit outside the hearing aid, and there is no worldwide standard. Specifically on the infrared system, there is no overspill, but it's partly standardized, but there are different standards, and it's sensitive to direct sunlight. The fundamental of loop systems is that it has a built-in receiver in the hearing aid. It has zero current consumption. The telecoil in the hearing aid doesn't draw any current at all, and it's a worldwide standard. In the loop systems of today, the receiver, the telecoil, is already built into the hearing instrument, therefore it's invisible. That means there is no need to learn a new device with on-off or channel switching. There is no additional external battery or charging system for the user to handle, and there is no current consumption for the telecoil. A loop system has a very long life compared to other systems. Once installed, no need for adjustment. The adjustments are done through the hearing instrument. Together with the hearing aid's individual hearing loss compensation and modern loop system, the speech intelligibility is very high. The loop system is compatible globally without any modification whatsoever. You can take a taxi in London, use Hong Kong Underground information platforms, and buy a ticket at the ticket office. This computer graph shows the vertical field strengths of a loop systems in different places of a room. This is the room, this is the level. You can see in the middle it's a bit lower, and in the corner it's a bit stronger. Very homogeneous, really. With computer, it is possible to simulate how loop systems will behave with different configuration. This shows what will happen in different heights. Please note that this is physics. It has nothing to do with the loop amplifiers by itself. International standard specifies the field strength. It specifies background noise, frequency range, the level, which is very important. It should be 400 milliamps per meter in the peaks for fulfilling the clarity and the less noise. There is a standard for the hearing aid sensitivity by itself. So the sensitivity of the hearing aid and the loop level must harmonize. The field variation should not vary more than plus minus 3 dB. I will now play 3 sound examples. This first one is with high background noise using a weak loop amplifier. The second example here, we still have the same background noise, but now with a stronger amplifier that will actually comply with the standard. But the noise is too high. Listen to this, please.
Og nu skal du høre om den grimme ælling.
You can now hear what's been said, if you're Danish that is, but the noise is very disturbing.
Og nu skal du høre om den grimme ælling.
Now we can hear that the noise has disappeared. It's the maximal allowed noise according to the standard. The field strength is also according to the standard, about 0 dB. Conventional loop systems do have overspill. This is a cross section of a loop system. The loop is placed from 0 meter to 10 meters. This is outside the actual loop, and you have the overspill there. You can see you have 4 meters outside. This minus 18 dB. That is very audible. With modern loop systems, you can have a very, very sharp cutoff, so there will be no overspill. A 3-dimensional figure, just looking at the overspill 1 meter outside, and you will see there is nothing below minus 48 dB. To summarize the standard, the level is very, very important, as we stated, because the hearing aid sensitivity and the loop should harmonize to each other. Do not trust the stated coverage area. That's very important. Remember that you should only trust what's been measured. You should certify them according to the IC standard. The level should be the 400 milliamps per meter, as I said. And you do that by measurement. But do not certify using a hearing aid. You can't do that because they are so different and they are fitted individually, so you can't use it. You need to have a specific instrument that measures the field strength according to the standard. Thank you very much for your attention. Bye for now.